Hey guys, what's going on? Today I'm going to be showing you how to schedule Athena queries. So we're actually going to be doing this through a Lambda function. Lambda is going to talk to Athena, tell Athena to do this every so often, and it's actually going to be triggered by a CloudWatch event. And we're going to use cron scheduling in order to set how often and at what times we want this Lambda function to trigger. And then it's going to go ahead and we're going to write the Athena query results to an S3 bucket, which you can use at your convenience later. So let's go ahead and get started. Let's go ahead and open up our AWS console. And we're going to start by creating a new Lambda function. So let's go ahead and open up Lambda, create function, and I'm going to go ahead and call this scheduled query, scheduled visitation query. If you've stuck with us, you know some of our previous stuff has dealt with visitation data from an SDK. So let's go ahead and do this in Python 3.7, and let's create a new role with basic permissions. Go ahead and create the function. This could take a second. All right, so here's our Lambda function. There's going to be a couple of things we need to import. Anytime we're dealing with accessing something like S3, we're going to need our Boto3 client. So import Boto3, and if Boto3 is going to be talking to S3, that means that it is going to need some way of having that access. So we're going to go ahead over to IAM. Let's go ahead and open up a new tab, open up our console. We're going to go ahead and look for Identity Access Management. And in here, we're going to go ahead and add a policy to our new role. And that policy is just going to say, we're going to give it S3 full access so that our Lambda function can talk to S3. So let's go ahead and look for our scheduled visitation query role, attach policies. We're going to type S3. And we're going to go ahead, give full access, attach policy, and you are all set. So going back to Lambda, the other thing we need is our trigger. So let's go ahead and set that now. We're going to select a trigger. We're going to look for CloudWatch events. Okay, for our rule, we're going to go ahead and create a new rule. Our rule name will be scheduled Lambda. And we're going to say this rule runs our Lambda every, let's say, 5 minutes. So our schedule pattern is going to be based on our cron expression here. So I'm going to open up cronmaker.com, and I'm going to say I want it by the minute and I want it every 5 minutes. Now cron, I don't believe does seconds. So we're going to go ahead and do it in minutes. So you're going to ignore this first 0 and you're just going to copy the rest here in our cron format. And then you can see the next dates that this will be scheduled. So let's return back to our rule, and we're going to go ahead and type in cron, and then go ahead and paste that and close that. Okay, and let's go ahead and add, and we will enable the trigger now, although not much will happen if it runs before we finish writing this. So let's go ahead back to our Lambda function, and let's get started writing it. Okay, so first I'm going to declare a couple of variables we need. You're going to need your database. So let's go over to, let's open up, actually we don't need IAM anymore, so we can use this. And we're going to open up Athena. So if you haven't made your Athena table yet in your Athena database, go ahead and check out some of my recent videos and you'll see how we can create an external table from JSON format in S3. And that's typically how you would control a data lake and querying in data lake. So here we call our table visitations, and it's in the database SDK data. So coming back, our database is SDK data. Let's set our table visitations let's set our S3 output, meaning where will the result of this Athena query go? So I'm going to go ahead and make a new S3 bucket. So let's go ahead over to S3. Okay, so I'm going to go ahead and create a new bucket. I'm going to name it Scheduled Visitation Query Results. And let's go ahead and create that bucket. Okay, coming back to our Lambda function, our S3 bucket is now S3 colon // let's check it just one more time. Scheduled visitation query results. Scheduled visitation query results. Okay, and our S3 bucket, we're just going to grab from that, is scheduled visitation query results. And I actually want our output to be in a folder that I will call unstructured. Because these Athena query results are kind of messy in their raw format. The last thing we're going to need to set is our retry count. So after we make our query and we execute our query, it's going to actually take some time. So we're going to have to go ahead and retry or recheck if our query has finished or not. So let's go ahead and create a function called execute query and pass in query. And I'm actually just going to return this for now, and we're going to go ahead and create an example query. We're just going to call this function, make things simple. So let's go ahead and I'm going to make this query points today query. And this query is going to get today's date, and it will check how many points I have in today's date, or how many rows in this table exist for today's date. So let's go ahead and get today's date by importing date time. Okay, so let's start by getting today's date. I'm going to say datetime.datetime.today. Our year is going to equal today.year. Month equals today.month. And our day equals today.day. And if you remember from previous videos, when we created our Athena table, we actually partitioned our data in such a way that if we query just today's points, it's going to ignore scanning over all other files. In other words, we won't be billed on scanning the other files, and we will just scan that one single folder. However, from our SQL query point of view, it will look like just a normal query. So let's go ahead and say query equals, and we're going to go ahead and select count as points from, and I'm going to go ahead and include these later. So that's going to be our database and our table. Where year equals, again, we'll include that, and month and day. And let's go ahead and fill those couple things in. So our first one is going to be our database. Our second one is going to be our table, then year, month, and day. All right. So our result is going to be execute what our execute query returns as a result. So let's go ahead and input that query, and we'll start writing our execute query now. Okay. So the way in which this works is that you'll use Boto 3 to access Athena. You'll go ahead and execute that query in Athena. But because it takes time to execute a query, you're going to have to go and check if the query has finished repeatedly until the point that it does finish, at which point you'll go ahead and grab the query result. Now, there are limitations on Lambda functions. So, for example, our timeout in a Lambda function has a maximum of 15 minutes. If we have a query, and it's very possible that we will have a query that exists for more than 15 minutes and it takes more than 15 minutes to run, then you're going to want to go and look up something called a step function or a state machine. And what this does is it splits your execution from your checking and your reading. So imagine splitting up 3 separate Lambda functions, and the first one will execute the query, and the second one will say, okay, let's check if it's done. If not, let's go and wait X amount of minutes, and then we'll go ahead and execute that Lambda function again to check if it's done. And when it is done, we'll go ahead and, with possibly another Lambda function, go ahead and read that query result. So by splitting it up, you use less compute resources, less compute time, and it is far more efficient for longer queries. So one thing we'll actually do here is just increase our timeout. So let's go ahead and increase our timeout to 5 minutes. And let's go ahead and save that. Okay, now to execute our query, we're going to need our Boto3 client. So let's go ahead and call client equal Boto3.client, and our client here is Athena. Our response is going to be client start query execution. And we're going to need to fill in some of these parameters here. So our first one here is going to be query string, and that's going to be our query that gets passed in. Our next one is going to be our query execution context, and that's going to be which database you want it to look at. So let's go ahead and say database, and that is going to be database. Okay. Next, we're going to need our result configuration. And that's going to be where we want the query output to write to. So we're going to write output location, although we're actually going to end up handling the output in this Lambda function. However, it does make it so that you can go back and find that query result if needed. Okay. So now that the query has been executed, first we're going to get our execution ID so we can check our query. So let's say query execution ID equals response query execution ID. Next, we're going to try to get our execution status. So for I in range 1 to 1 plus retry count. Again, this is going to be our loop of checking to see if the query is done. And if not, we're going to go ahead and wait I seconds. So let's get our query status with our client. So client.get query execution. And our parameter is going to be query execution ID equals query execution ID. We're also going to need our query execution status by looking at what it returns as a nested object. So query execution status equals query status query execution. If you go ahead and print your query status out, you'll see the nest that's available, and that we want our query execution, we want our status, and inside of that we want our state. And then we're going to say if query execution status is succeeded, which it'll return if it's done, then go ahead and print out our status and our query execution status. And then we're going to go ahead and get that result. So get query result. And we're going to need our query execution ID. And you can go ahead and return that result. And if our query execution status, looks like we made a little typo here, execution status, and we're going to go ahead and fix it there too. You'll have query execution status equals failed. We'll go ahead and raise an exception. And we will go ahead and print that query execution status. Else, we'll go ahead and print status and print our status again. And this else is going to be if our query is still running. We're going to go ahead and sleep for I seconds, and then we'll go ahead and check again. The queries I run are going to be anywhere between 1 to about 20 seconds. However, if you have query after query, it can certainly add up. And if you have a lot of data, it can add up even more. So again, check out those step functions and state machines. Okay, now if we exited this for loop and we didn't end up returning our result, we're going to go ahead and handle that here. So let's go ahead and stop our query. So client, stop query execution. And you're going to need your query execution ID. And again, we're going to raise an exception. And we're going to say time over. And hopefully our Lambda function will be longer than the total possible sleep time. So you're going to want to go ahead and check that when you're creating this. Okay, now our query has been returned, and that's actually going to be kind of a nested object. So we'll go back to our point state query, and we have this result. So to get our actual result of the count as points, we're going to go ahead and check that nested object. Here, I highly suggest printing it and going ahead and testing this function, and you'll see what that nested object looks like, or you can see in CloudWatch logs the output of this. And again, you can look at your unstructured query results. So let's go ahead and we're going to get our points equal to int of result, our result set, our rows, and we're going to look at the second row, and we're going to look at the data of that row. We're going to look at the first result, and we're going to look at the varchar value. Again, very nested, highly suggest checking it out. So now I'll create my results dictionary, and I do this for most queries by making it into a JSON object or a dictionary converted later to a JSON object during saving, just because it's a little easier. And I'm going to call this results dict data, and I'm going to go ahead and set it equal to value points. And then I'm going to go ahead and save my file. Now, to make things easier, and because we're going to do this a couple times anytime you make an Athena query, I'm going to make saving a file a little easier. So let's go ahead and define our save file. And we want our file name and our dictionary object. So let's go ahead first and specify our file path. And I want this now to be our structured result. And I will include my file name and make it a .json. And then I will go ahead and create a different Boto3. This time it's going to be a resource, and we're looking at S3. And we want the actual bucket of R, as we defined earlier, our S3 bucket. And I'm going to create something called dump S3 as an extension of JSON. And that's actually going to be a Python Lambda function that will take in a object and a file path. So let's call that obj_n_f. It's going to go ahead and dump this JSON into our S3 bucket and our S3 path. So S3.object key equals f dot put, and our body is going to be equal to json.dumps object. Okay, so now let's go ahead and call that json.dump s3, and we're going to include our dictionary object and our file path. And we're going to go ahead and return. So coming back to our points today query, we need some way of saving this object to our file as specified. So let's go ahead and call save file, and I'm just going to go ahead and name this total points. I will write our results dict and go ahead and return. Now the only thing we're missing here, and if you were here last video, you'll remember me saying this, we need to repair our table. Now what this means is anytime you partition your data, Athena is not aware of partitions that have not been seen yet. Meaning, let's say it's a new day and I've gone ahead and written new visitation points to our year, month, day directory, and we have that JSON file. What we need to do is repair the table by calling this Athena query. So let's go ahead, and you're going to want to do this before actually calling your points today query. And I will call this prepare table. Without this, you won't actually, your table will query without actually seeing the new data that has arrived since the last time you've repaired your table. So prepare table, and let's go ahead and assign our query, and it is going to be just as before, msck repair table, and we will input our database and our table. And go ahead and execute that query using the function we created earlier and return. Okay, now that we have it all set up, let's go ahead and first call prepare table, and then we will call our points today query. And let's go ahead and save that. And the next thing we're going to do is go ahead and test it. Create new test event. This really doesn't matter since we're not taking in anything from our event. Let's go ahead and give it a name. I'm just going to call it test and hit test. All right, so our Lambda output, it looks like we had a small typo here. Instead of query execution content in our start query execution, we're going to go ahead and change that to query execution context. Go ahead and save and test again. Okay, and so here we are with another error, and this one says that the role is not authorized to perform the Athena query. So let's go ahead over to IAM, and we need to add one more policy to our role. So we've given it S3 full access, however, it does need access to Athena. So let's go ahead and open up IAM. let's go over to our rules. And let's go ahead and find our scheduled visitation query rule, attach policies, search for Athena, and I'm just going to go ahead and give it full access. There we go. Now let's test it one more time. All right, and there you have it. You see that our status is succeeded, and our duration of our query was about 11 seconds. Couple small things to note. I did have a couple small typos in there that I fixed up. Most notably, it's get query results rather than get query result. And if we go over to S3, you should go ahead and see our structured data. So let's go ahead over to scheduled visitation query results, structured, total points JSON. Go ahead and open this. And there it is. We have our data value 0. All right. So thanks for watching. If you stuck with us, you saw us schedule Athena queries using CloudWatch events as our trigger, using cron expressions to trigger this Lambda every 5 minutes. And then that went ahead and got access to Athena using our Boto 3 client. And it used those Athena queries, retrying it in a loop and writing to our S3 bucket. Now, I'm not going to make a video for it, but I actually did go ahead and create an API gateway that uses a Lambda function proxy that goes ahead and picks up that file JSON in order to return to the admin dashboard that I've created to understand our data and how many points are coming in each day, etc. So if you enjoyed the video, go ahead and like and subscribe, and I will see you next time.